Okay, in this one, I've already loaded my R commander, and I've already gone ahead and loaded my data set, which I've named cybercrime. In this one, I'm going to do a generalized linear model to predict how many average cyber attacks a person should expect given the factors for the next month. So first we're going to go ahead and with our data, just view our data overall, see how it looks. And then we're going to go ahead and we'll do some summary statistics, sure. And that will show up. It shows up some stuff here from before. So it shows up right down here. Okay. So we can see some of the summary statistics for each of them. Then I'll go ahead and I'll fit the linear model. And I'm going to call this General Linear Model 1. And I want to predict that one. So let me add some factors here. I'm going to go ahead and add firewall, frequent traveler, malware, online banking, secure HNet, security clearance, total kids, and I'll go ahead and I'll add if they have a tablet. I'm use the Gasan model. Logit function, press OK. Yes, I already have this model. And it shows up down here. So actually all of these are significant, which is interesting. That's nice news. So from here, I'm going to go ahead and with my model, go ahead and run some. Let's look at some outliers. So that does give you some outliers from your model. It tells you what outliers. And then I'm going to go ahead and run some basic diagnostic plots on this model. So it gives you the normal QQ plot, residuals versus fitted. You can get an idea, and you can kind of see those on there from the model. And finally, I am going to run, let's do a multi-way Anova. Now here, I'm just going to pick the ones that I had. So let's see, I had, just pick a few. Response variable, that. Let me check if they have a cell phone or not. And social network. And let's just look at that. Let's just see what that looks like in response to that. And I'm gonna call this cyber. Even though those aren't in the model, it'll be interesting to see. It just gives you the number of counts and the means, so yes and no and yes and no, and the probability. So there we go. For there, for the models, for just those which are not included in the model, and they don't need to be included in the model. So after this, I'm going to do an Anova table on the actual model itself. And I think it caught my last one. Yes, it did. It actually caught the last one instead of my other model, which was GLM1. So let me go ahead and change that. And I'll do, and the R commander, you can just write GLM.1. And you can go ahead and just submit. Or I guess I got that wrong, didn't I? Let's see. So instead, I'll go ahead and do it this way then. Okay, so here we go, and this confirms my general linear model, which is nice to have. So then my R commander, I'll take out the one that I didn't put the name in right. And I'm going to, okay, and then I'm going to look at my markdown here. I'm going to take it down there as well because I don't want that to show in the markdown. So now I'm going to go ahead and generate my markdown report and see what it looks like. So it'll pop up, blocked content, and it shows everything that you've done, your model, all of your plots, all of your testing, your Anova table, and it outputs everything. So this is how you would make a generalized linear model to predict the number of cyber attacks, the average number of cyber attacks predicted for next month based on the significant factors. And we verified it with some plots as well as the Anova.